Has to warm up. There you go. So it makes this oval shape. So we have vertices and we have co-vertices. We have a minor axis and a major axis. Okay, so an ellipse is the set of all points in a plane such that the sum of the distances from two fixed points is constant. These 2 points are called foci. Okay, so your foci points are these F points right here. Those are your focus points. Every ellipse has 2 axes of symmetry, the major axis and the minor axis. So your major axis is the longest one. Minor axis is the shorter one. Okay? So in this one, your major axis would be this longer one. Minor is the shorter one. Okay, so the major is between your vertices. The minor is between your co-vertices. The foci of an ellipse always lie on the major axis. The endpoints of the major axis are the vertices, and the endpoints of the minor are the co-vertices. Okay, there are several important relationships for an ellipse. The length of the major axis is 2a units. Okay, so you're going to need that a value in order to set up an equation. Okay, so your major axis is 2a units. So you can take that major axis and divide it by 2 to get your a value. Okay? The values of a, b, and c are related by this equation here. C squared is equal to a squared minus b squared. Again, those are for your major axis, minor axis, and your foci points. The distance from a focus to either co-vertex is a units. So just like what we had before here, we have a chart at the bottom that's going to help us set up these equations. Okay, so we have 2 different forms. We have a horizontal ellipse and a vertical ellipse. So for your horizontal, this is your standard form. It's x minus h squared over a squared plus y minus k squared over b squared equals 1. Your ellipse will always equal 1. Always equal 1. Okay, unlike circles where you had the radius squared, ellipse will always equal 1. For your vertical standard form, you have y minus k squared over a squared plus x minus h squared over b squared equals 1. Okay, so the difference between this is where your a and b are placed. If you notice in your horizontal one, you have a squared is under x minus h, and a squared here is under y minus k. Okay, so that's why they're different. Okay? Same thing with your vertices, your foci point, and your co-vertices. So for these ones right here, you need to be looking at these as we set up those equations. Okay, so if you have k the same for your foci and your vertices, you know it's going to be horizontal. If you have h the same for your foci and your vertices, it's going to be vertical. Okay, that's the kind of stuff that you need to look for when you're given certain information. Okay, so today, just like we did with circles and parabolas, I'm going to give you the graph, and we're going to write the standard form given that graph first. Okay, because I think that's sometimes easier to just visualize what's going on. So if you flip it over, okay, we only have 2 examples here. So in both of these, we want to write an equation for the ellipse graphed at the right. Okay, so here's our graph. Now, our ellipse here would be a vertical ellipse. Okay, we can tell that just by looking at it because we're given that graph. So we're going to use that vertical equation. So that's what I want to identify first. If it's horizontal or if it's vertical. This one's vertical. Okay? To set up that equation, I have a couple steps. First step, I need you to do is find the center. Okay, just like we did with circles, you need to find the center. Well, we're given this graph, okay? Our center for this one is going to be 0, 0. Okay, when you're given the graph, it's easy to locate that center point. Okay, so this one is 0, 0. Okay, and just like before, that's going to be your H and K value. Okay, step 2, you need to find A. Okay, we have that A squared value in our equation and we have a B squared value in our equation. I need to find A. So A, again, is half of your major axis. Okay, so your major axis is that distance between your vertices. Okay, so my major axis is this long right here. So I can count how many that is. Okay, that's your major axis. So you take 10, and that's divided by 2. Okay, so that's your major axis, divided by 2. So our A value is going to be 5. Okay, step 3 is to find B. I'm going to show you a different way. You can take the minor, what we just did, but with the minor axis and divide that by 2. Okay, it's easy on a graph to do that, but when you're just given coordinates, I'm going to show you another way you could find B. So finding B has to do with your co-vertices. That would be these 2 points here. Okay, so this point would be at 1, 2, 3, 0. Okay, so I can use that coordinate point. Now if I look back at my front here, and I know this is a vertical, okay, with my co-vertices, I can find B right here. I can take H plus or minus B, and it should equal my co-vertice. So I'm going to take my 3 value here, and that has to be equal to our H value plus or minus B. B will be 3. Now your A and B values are always going to be positive. Okay, so they should always be positive. So that's another way you can find A or B. You could have done the same thing with A using one of your vertices and your K value. Okay, so if I would have done that here, that would have been 5 is equal to 0 plus or minus A. Okay, so there's different ways you could go about solving for A and B. So now that I have my center, my A value, and my B value, the last step is to write the equation. Okay, so I'm going to use my chart on the front. Again, this is a vertical ellipse. Okay, so I'll take y minus k is 0 squared over our a squared value. So a is 5. That's squared. With ellipses, there should be a plus between the two. Then we'll have x minus h, and h is 0, squared, over our b value is 3, squared, and our equation is always equal to 1 for an ellipse. Okay, now I can just kind of simplify this a little bit. If I have a y minus 0 and an x minus 0, I can just write that as y squared instead of with that minus. However, if you keep that minus 0 in, it's not incorrect. Then I'm going to square 5. 25. I have plus x squared over 9 is equal to 1. And that would be the equation for this ellipse. For an ellipse, it's always equal to 1.
Always equal to 1?
Always equal to 1. Do you have a question? Which one? This one? This one? This is from K. Our point is 0, 0. That's our center. K was 0, H was 0. Got it? Yep. Major axis, if you're given the graph, you can just count. It's the distance between your two vertices. And then your minor axis is the distance between your two co-vertices. Other questions on this first one? All right, then we're going to do this last example here. Last example here. This ellipse, vertical or horizontal? Horizontal. You always want to check which direction it is first so you know which equations to use. Okay, so this one is horizontal. Okay, my first step again is to find the center. Okay, where's the center of this ellipse? 0, 0. Okay, that's your h and k value. Okay, step 2 is to find a. Okay, again, there's multiple ways you could find a. You can count from your vertices, so from this -9 to this +9 would be what? 18. Okay, you need to take your major axis of 18 and divide it by 2. Okay, so a will be equal to 9. Step 3. Okay, we need to find B. Now B has to do with your minor axis. Your minor axis is from your co-vertices. Okay, so I go from 4 to -4. That distance is 8. So I'm going to take my minor axis of 8, divide it by 2, and B will be 4. Okay, now for each of these you could have done it different. Again, using this table on the front, we knew this was horizontal. You could have taken your vertice using H as 0, plus or minus A, and that should have equaled 9 or -9. Okay? Last step, step 4, is to write out your equation. Okay, so I have H and K, and I have A and B, and this one is horizontal. So we'll have x minus h. H was 0, that's squared, over a squared, so 9 squared, plus y minus k, again k was 0 in this case, over b squared, so we'll have 4 squared, and that will be equal to 1. Yep. Okay, now I can just simplify. So I have x squared over 81, y squared over 16, and that's equal to 1. Any questions? Does that make sense?